To give up, you have to be dead, or completely incapacitated.
Good morning, darling. Brace yourself. Knowledge is coming. I kinda losing the plot. Let's get back to dumbing down things to imbecile level. Agenda. CCNA. DevOps. Python. Acronyms. Cosmos. Trader and economy. Git. Algos aka algorithms? Maybe. So CCNA. IP addressing basics. Previously on redo to die for the grill. Default gateway. And now TCP IP addressing. And understanding binary. So, lad, IP address is a 32-bit address divided into 4 8-bit octets. These 4 octets are normally displayed as decimal values, but they also have a binary representation that look like ones and zeros. Meaning 32 zeros and ones. You do not want me to spell it out for you. 1100000010101000 and on. Anyway. Notice that there are 4 sets of 8 bits. Meaning in a 32-bit address there are 4 setters of 8 bits. Oh my god. Really? Okay. Fine. But now I will try to show you with my words how decimal numbers are converted to binary. Oh my god. How? We start Yiddish style. Meaning we number things from right to left. 1 to 128. Each step doubling the number. So. 1, 2, 4, 8, 16, 32, 64, 128. You get the idea. So you have 8 decimal numbers and 8 bits. So every bit, in its particular location represents some corresponding number. For example, if we have 8-bit number like 1 and 7 zeros. This binary number represent decimal number 128. Since if we double the numbers like I did, 8th number would be 128. And since we do the Yiddish thing from right to left, you get the idea. Right? Damn, son. Let's try again. 8-bit number is a number consisting of 8 ones or zeros. 8-bit number always has 8 digits. However, since it is binary the digits could be only 1 or 0. Also, if you have leading zeros, you should be not dumb enough to understand that leading zeros does not matter, right? Since if I gave you $1 or $1 you would still be poor like you are. But if I gave you $10, which is not leading zero, you would be rich as a flunker with some exotic grill and nice Audi e-tron. What is e-tron in French? Anyway. So, 8-bit number is 8 digits number, if you do not exclude leading zeros, which you do not, son, come on. Okay. Fine. Now I guess you know that we write numbers from right to left, right? Meaning 100 is 001 from right and 10 is 01 from right. So, example, number 10 million would be 1 and 7 zeros, but it would be 000 and 000 and 01 from right to left. Oh my god, still going on about this? Damn, son. It is no even funny anymore. Ha ha. So 10 million or binary 1 and 7 zeros is 128 decimal. Since if you double 1, 7 times, you would get 128, right? 2, 4, 8, 16, 32, 64, 128. Boom. Boom? Do you get me, son? Not likely, but. The first bit is known as the least significant bit, or low order bit, while the 8th bit is known as the most significant bit, or high order bit. Why? Do not ask me, son, ha. Let's calculate some value, let's say 192 decimal value. Let's convert it to binary. Damn, this is painful, ha. By the way, 0 and 1 is like off and on, right? You knew that? So 8-digit number, binary number, is like, example, 10 million, on and 7 offs. Now let's get back calculating aka convert 192 decimal to binary. 192 is 128 plus 64. So first 2 bits are on. And last 6 are off. So 11 and 0000000. I guess you got that right. Will you be calculating this stuff on the job? Who knows? Should you practice maybe? Maybe? Okay. Fine. But next address classes. Which total nonsense, ha. There are no classes these days. But I guess it is good to know the history, aka 1990. There are more classful addresses. Classful addresses is like classless addresses with specific subnet mask, so what is the point of it, son? But now. What? DevOps? DevOps? I don't know. What about figuring out the infrastructure of the bank IT? I found some 2017 image. There is a heavy use of VPN connections. Virtual private networks. Anyway. I also found this in bank architecture reference. This one is like more promising, aka better looking. Let me try to show you with my words. First we have 3 groups. Users, cloud and enterprise. So users. Users are divided into external data providers and ecosystem partners. Second subgroup in a user group is traditional and new banking channels. So user group and provider and partners subgroup. Peer cloud. Ecosystem partners. Demographics, FICO, credit, merchants, blockchain network, correspondence bank. Okay. Fine. This means very little to me. Now user group and traditional and new banking channel subgroup. Customer, bank teller, relationship manager, call center, internet banking, retail banking, contactless banking, ATM. So. This user group from those 2 subgroups merge into edge services. And those edge services go to API management. So basically from the user group everything goes to API management. Let that sink in. Sleep on it. Boom. Now but. Python. Should I even? Okay. Fine. Python integers. You may already know a little about how computers perform calculations on numbers. Perhaps you have heard of the binary system, and know that it is the system computers use for storing numbers, and that they can perform any operation upon them. Okay. Fine. Maybe. I would not explore the intricacies of positional numeral systems here, but we will say that numbers handled by modern computer are of 2 types. On ICE integers, that is, those which are devoid of the fractional part, meaning no number after the comma or dot, depend where you live. And, also, floating point numbers, or simply floats, that contain, or are able to contain, the fractional part. Do you get me, son? This definition is not entirely a Kirkut, but quite sufficient for now. The distinction is very important, and the boundary between these 2 types of numbers is very strict. Both of these kinds of numbers differ significantly in how they are stored in a computer memory, and in the range of acceptable values. The characteristic of the numeric value which determines its kind, range, and application, is called the type. If you encode a literal and place it inside Python code, the form of the literal determines the representation, type, Python will use to store it in the memory. For now, let's leave the floating point numbers aside, we will come back to them soon, my son, and consider the question of how Python recognizes integers. So. But now, let me see. The process is almost like how you would write them with a pencil on paper. It is simply a string of digits that make up the number. But there is a reservation. You must nor interject any characters that are not digits inside the number key. For example, the number 11,111,111. Let me try like this, 11,111,111. Altogether 11,111,111. Okay. Fine. If you took a pencil in your hand right now, you would write the number like, whatever. Next. It is clear that this provision makes it easier to read. Like commas or dots or spaces between digits, especially when the number consists of many digits. However, Python does not accept things like that. It is prohibited. What Python does allow, though, is the use of underscores in numeric literal. But now, Python 3.6 has introduced underscores in numeric literals, allowing for placing single underscores between digits and after base specifiers for improved readability. This feature is not available in older versions of Python. Older than 3.6. So now. Therefore, you can write this number with a lot of ones like 11,111,111. Okay. Fine. But what about negatives? Like just put a minus sign in front. Damn son. You could put a plus sign if you want, but that does nothing special. It is the same if you did nothing. Boom boom Python fin. Day what? Day 5. CIFS, Common Internet File System. CNAME, canonical name. COS, class of service. CPU, central processing unit. CRAM, MD. 5. Challenge response authentication mechanism, message digest. 5. CRC, cyclic redundancy checking. CSMA, CA carrier sense multiple access or collision avoidance. CSU, channel service unit. CVE, common vulnerabilities and exposures. CVW, collaborative virtual workspace. Now maybe Git and other IT stuff before we go into those Trang and Cosmos, not really that important stuff. So Git object types. I think you know that there is hidden Git folder. Of course. It is highly not recommended to make changes in Git manually. Also Git has its own file systems and stores its own objects. So. There's several types of objects that Git can store. So those objects are blobs, trees, commits, annotated tags. These 4 object types allow Git to store all the necessary data, changes of files and so on. So what those object types represent, let's make a short overview. In blob object types, Git stores files. Any files with any extensions, either video files or pictures or text files, any files of any types are stored as blobs. Next, trees. With the help of tree object type, Git actually stores information about directories. And the same as in any other file system, directory may be empty or contain files or contain other directories or mix of files and directories. Same here. Tree in Git may be set of blobs or set of blobs and other trees. Again, tree is a representation of folder or directory in Git aka Git. Next object type is commit. And with the help of commit object type, we are able to actually store different, let's say, versions of our project. And last, but not least, object type is annotated tag. Annotated tag is actually a persistent text pointer to a specific commit. So let's talk about blobs. Blob represents a single file in a Git file system and tree represents directory or folder. And for management of blobs entries we will use so-called low-level Git commands like git --object and git cat-file. With the help of git --object command, we will be able to create new object in Git structure. With the help of git cat-file command, we will be able to read Git objects. Boom boom boom. I guess it is useful, yeah. So son. Let's focus on the IT and skip trader? Maybe. Mixed feelings about this. Bye bye.